Hey guys, this is just a video to show the equipment you need for the balloon balance. So you need a ruler, you need 2 balloons, a balloon pump to pump them up. This might take a really long time, so you might want to do it before class. You can blow it up with your mouth, but it's really hard to make them even because you want the same amount of air in each one. So it's kind of up to yourself. You need 1 long piece of string to tie around 15 centimeters at the center of the ruler, just so it can be a balance like that. And then you need 2 pieces of string that are equal length, because that means they're going to be equal mass as well. And you tie one of these around each of the balloons and put them equidistant, so like at 28 and 2 centimeters, so that it'll balance. It won't be lopsided. If the balloons aren't the same weight, you can move the heavier one inwards a bit more, like 27 centimeters or 3 centimeters, whichever, because that'll just make them balance a bit better. And then you also need a scissors to safely cut the balloon without making it explode. I will put a video up on this as well, but that's all you need. And the setup is literally just tying this long string around. There'll be another video about this as well, and then the balloon on either side with equal lengths of string. I think that's it. Okay, sorry. This is the setup for the balloon balance experiment. It's really simple because it's just air. So what this experiment is trying to show is that air has mass, it has weight, and it's present. So we have a string going up here that's held in the center of the ruler. These 2 balloons were blown approximately the same, but that's really hard to do. These strings are the exact same length, and the balloons are the same balloons. So it should be equal. If they're not equal, you can put the heavier one closer into the ruler. They should also be equidistant from the ruler, so about like 28 2 centimeters. This one's at 27 because it's a bit heavier, just a bit less even. And what you're going to do is you're going to safely burst the balloon. Brilliant. So you can see these haven't changed, the string hasn't changed position, but this one is now heavier, it's not balanced anymore. And that is because gas has mass. It is there, it is present. Hey everyone, this is a video about air taking up space and air having mass. It'll go with the balloon balance experiment if we do that one. So what you have here is 2 bottles. There's a hole in the top of each one, and there's a balloon going through. So you'd ask the kids, okay, what's the difference between the 2 bottles, apart from the difference in colour of the balloons? They might say nothing, and we'll be like, well, there is a difference, and we're going to show you what it is. So you try and get make this as visible as possible. You blow up the first balloon, and it's really hard to blow up. It only goes a little bit. You let the air out again. Then you blow this one up. And this one blows all the way up. Why is that? You can give the kids, like, you can get an assistant up to try, because you can feel the pressure of like not being able to pump this one, and you can pump this one. The difference between the 2 is that this bottle, I'm not sure if you can see it, has little, oh there you go, has little holes in it on either side. There's another one here. So this kind of shows, like, it demonstrates air pressure, but basically if there's air in this bottle and there's air in this bottle, but when you're pushing more air in, you can compact the gas, compress the gas. You can make it as more pressure, tighter, I suppose, or you can let it out. But you will only be able to get a certain amount of gas in here before you can't pump it any further, or the bottle will explode. But I don't think we have the power to do that ourselves. We're not strong enough. But with this one, the gas is being let out, so we can blow the balloon up the entire way down. And this proves that air takes up space, and like whatever gases that seem like they're nothing, and it seems like it's just empty space. It's not. There's atoms there, there is stuff there. And that's just the idea that you're trying to get across with this demonstration.
Thank you for watching and listening! Created using Powtoon.